Hello students, this is the first video lesson for the fourth unit, which is about transformations. Today we're going to be talking about identifying transformations. So a transformation is just changing a prior shape into a new shape in some specific way. There are a couple of different ways that we can talk about transformations. Flips, slides, turns, and grow, shrink. Those are like the colloquial ways of saying them, like the way that you would talk about it in English. But in geometry, we have some very specific methods or very specific terms we use. Translation is when you slide, reflection is when you flip, rotation is when you turn, and enlargement or dilation is when you stretch it or shrink it. Moving on to the learning target. In the learning target for today, we're going to apply concepts of rigid motions. Rigid motions are three of those four types of transformations that we talked about, either reflections, rotations, or translations. Those are stated here. And we're going to be identifying them. That's a really key word, right? Identifying translations, rotations, and reflections. You need to be able to look at a diagram and say, well, I think that this was a translation. I think this was a rotation, or I think it was a reflection, and then give a good reason as to why. Take a look at the do now. There are a couple of different images here. We're going to describe the images and specifically how they're altered. I'll go ahead and pause the video, try this one out, and then see if you got it right. All right, you should have gotten that this was a reflection. We call it a reflection because it's flipped over a straight line. That definition of a straight line is called the axis of reflection. So this dotted line is an axis of reflection because we've flipped this pre-image over onto the image. This one is called a rotation. We're rotating around a central point, right? If you imagine that there's a central point on top of this figure's head, they're rotating around that point. That's called the center of rotation. And then this one is called a translation. We took the same exact picture and just slid it. We didn't change which way it is pointed or which orientation it had. We just slid it along this directed line segment, which is called a vector. And to remember these three different terms, reflection FL is a flip FL. Rotation with an R and a T is a turn with an R and a T. And translation SL is a slide SL. Moving on to some definitions, let's take a look at the definitions of transformations in general, and then the specific transformations we're going to be talking about today. So starting off from transformations in general, a transformation is any type of change from a pre-image to an image. So you can consider these triangles, the ones that are pointed to the right, are the pre-images, and these are their images, which I'll differentiate with different colors. So you can see the pre-image, the black triangle turned into this red triangle from a rotation. Then this black triangle, the same pre-image, turned into an image by translating or sliding. This pre-image turned into this image from flipping or a reflection. And then this pre-image turned into this purple image from stretching or shrinking. That's called a dilation. Moving on to those specific definitions now. All right, rotations first. A rotation is a turn that moves the object around a point. That point we labeled here is the COR, the center of rotation, and it changes its direction. You can see that this triangle was pointed upwards. Once you rotate it, it can be pointed, to the right or downwards or to the left. All it's doing is changing its direction, right? For a translation, it's a little bit different. And next we can talk about translations. Translations are slides that transform an object, changing its position. Notice that from the original, the pre-image to the image, all I've done was slide every point along the same exact vector. So you can see this point went upwards and to the left, this top point went upwards and to the left, and then this bottom point is going to move upwards and to the left as well. And they're all going to be moving by the same exact amount. We're going to be talking about how to identify translation vectors during that second lesson. And we'll talk about how to slide along a vector, which is just a change in the x and the y of each point. Next, let's talk about reflections. Reflections are flips that transform an object that change its orientation. Now, when you think about flipping over a line, that line is called the axis of reflection, the AOR, and we drew in this axis of reflection here. This axis of reflection allows us to take every single point from the original, which is called the pre-image, and turn it into a new image on the other side of that axis of reflection, the same distance away from the axis of reflection for each point. Now, all three of these, rotations, translations, and reflections, are all the same in that they preserve the shape and the size, right? So all of these have the same exact shape and the same exact size. So we call these three different types of transformations: rigid motion. That's what I labeled in here. The rigid motions have the same shape and the same size. That's important. Now there's one transformation that does not preserve size. As you can imagine, that would be the dilations, otherwise known as the stretching or shrinking. And here is the definition for that. A dilation is a transformation that stretches or shrinks an object, changing its size. So you can see that we have a pre-image here, the black triangle, which became this purple triangle. You can see that it stretched itself out. It looks like maybe a dilation of about 2. And the way that we determine the size of a dilation is to say, well, whatever this dimension is, how much did it get multiplied or divided by in order to get that new shape, that image? That's your method of finding out a dilation. And I put that there for your reference. The scale factor is how much the shape is multiplied or divided by. All right, moving right along, let's take a look at some model problems. In the first model problem, we're supposed to draw this letter R 90 degrees counterclockwise around point A. Now keep in mind, counterclockwise and clockwise are something that you're supposed to know before you come into geometry, but in case you didn't know, here's what you should know. If you were to watch an analog clock, which this is, an analog clock is the opposite of a digital clock. If you were to look at an analog clock and watch the direction in which the hour and minute hands spin, they always spin around this way. I guess you could consider it to the right, but people try to avoid the terminology to the right. We call this going clockwise. And if things were spinning around this way, well, first of all, that would be very disturbing to watch a clock spin this way, but this way in this direction is called counterclockwise. So as a reference, this way is clockwise and this way is counterclockwise. Let's see, now let's actually try to draw that letter R 90 degrees counterclockwise around point A. So here's point A, here's that letter R. Let's trace this out a little bit so that we can actually use the shape to inform us of what it should look like later. All right, here I've traced it around, and we're supposed to rotate it 90 degrees counterclockwise, which means I'm going to be spinning it around that way. So I'm going to bring this down. I need to bring the other part of it too, excuse me, so that it's underneath this point A. And it should be about the same distance away from A, so it should be down here-ish. Now, a rotation does also mean that we're taking the shape and spinning it around, right? The rotation is turn. So what we're going to do is turn it like this, so it looks like it's lying down on its side. You can see now that this rotation, this counterclockwise rotation, brought it around 90 degrees. Why do we say 90 degrees? Well, here's why. You can imagine this letter R to be tethered to this point A, kind of like maybe a dog is tied to a leash that's, connected to a stake in the ground. If I were to spin this R 90 degrees around, it forms a 90-degree angle to where the leash was as compared to where the leash is now. So that 90-degree angle indicates that I've rotated it around 90 degrees counterclockwise. And you'll also notice if this was a dog on a leash, you would know that the leash couldn't, grow longer. So this distance from the center to R is going to be the same distance from the center to the new R, from the pre-image to the image. What object was R rotated around? Well, I think we know the answer to that question. We refer to this object as point A, which is the center of rotation. We rotated it around point A. The general name for this object for any rotation, as stated previously, is the center of rotation. Next, we have to describe the direction in which R was rotated. We can say that it is rotated around the shape, but I don't really want to say left or right because that's a little misleading. The way that you refer to how something is spun around a center of rotation is to either refer to clockwise or counterclockwise, and in this case, it was counterclockwise. And just so you know, if the problem asks you to do a rotation and it doesn't specify which direction you're supposed to spin it, this is the default direction for any rotation, counterclockwise. Can you rotate the figure in any other ways? Well, sure, we can rotate it further in the counterclockwise direction. We can take the R and spin it over to this side and then spin it up here as well. Or we could rotate the figure so that it's going the other direction, going around clockwise. You have many different options. So that informs us that when you're talking about rotations, rotations are talking about direction of rotation and degrees of a rotation. So that's what you need to specify when you say you're going to do a rotation. Moving on to model problem number 2, it's asking us to draw letter R reflected over the line M. And this over here is a capital M. It actually should be a lowercase m because we labeled the line as lowercase m. So now I'll do the same thing as I did before. I'll trace over letter R, and hopefully this time I do a slightly better job. And then I'm going to try to reflect it over this line, which is called the axis of reflection. And there's our shape, just as if we were looking at it in a mirror. There are a couple of things that you should recognize about this. Notice that R, the original shape, the pre-image, is the same distance away from the axis of reflection as the image is. I'll show you. So any point that you choose on the pre-image, it's going to be the same distance away as the that same point on the image. Now, what object was R reflected over? We talked about line M. Keep in mind that line M is called an axis of reflection. And in fact, any reflection is going to have that axis of reflection, a straight line over which you reflect the pre-image to make an image. How does the letter R look different? Well, you can see that this letter R is sort of oriented in a certain way. Once you flip it around, the orientation changes. And when I say the orientation, I'm talking about the way in which the points are ordered. Like if I go around the shape from this point around to this point, I can say that I'm going from here up, over, and around. That's in a clockwise fashion. From this image, if I went from the same exact point around, I would be going up, over, and around in a different way. That's a different orientation. And as I said here, the orientation is just the way in which the points are ordered. They're ordered in the opposite way, clockwise versus counterclockwise. For model problem number 3, let's take a look at letter R, and let's try to draw it 2 centimeters to the right and 1 centimeter up from its original position. Again, I'll trace the shape. All right, I've traced my shape here, and it says 2 centimeters to the right and 1 centimeter up, which means I'm going in this direction by 2 centimeters and then 1 centimeter up. Okay, so not bad. And what you should notice is that everything about this shape looks the same as this shape. Well, excuse my drawing, but it's been shifted over or slid over and up. And we can talk about this dotted line as a vector, or in other words, a directed line segment that shows us the direction in which we're going and the distance in which we're going. We've gone 2 to the right and 1 up. And if we take this vector and duplicate it, it shows that we are able to start from any point on the original shape, the pre-image, and if we start it from there, we'll get exactly to the image. So let's do that one more time, starting from the back. And you can see that we can drag this over, and it exactly matches up with the bottoms of the 2 R's. And now that I've already given away the answer, the question is, what is the general name for this ray for any translation? And that would be the vector. We call these vectors of translations, or simply vectors. It's an increase or decrease in x and y, and in this case you can tell that we increased in x horizontally by 2, and we increased in y vertically by 1. And it indicates where the image is going to be in relation to the pre-image. There's one more thing that we have to talk about before I end the video, and that's the word corresponding. That word corresponding indicates the same exact part, but in a different shape. In other words, the same exact part in between the pre-image and the image. And of course, I wouldn't tell you this definition without giving you an example, so let me give you a quick example of this. They're in the same place but different shape. Corresponding parts of a pre-image and an image are in the same place for the 2 shapes. So for example, I'm looking at this, which is the pre-image, which is line segment GY. That corresponds to this line segment, which is G prime, Y prime. And that prime indicates that it's no longer the original image, it's now it's no longer the original pre-image, it's now the image. So GY turns into G prime, Y prime, and these 2 are corresponding parts. Same thing here. I'm looking at the quadrilateral, the 4-sided shape FREI. I'm looking at IF, which is here, and that line corresponds to, or that line segment corresponds to, this line segment, which is I prime, F prime. They're in the same place, but they're in different shapes. One more, I'm looking at CZ, which is here on this quadrilateral. This is the pre-image, and the image is C prime, Z prime. It's the same place, but in a different shape. When you're doing these check for understanding questions, you're going to be identifying each transformation and specifically saying why you think those transformations are what you say they are. All right, that was the video on identifying transformations. Good luck studying.